Welcome to the Geometry Unit 7 practice test video. Laid out on the screen now, you can see the answers to the first 10 questions. I'd highly encourage you, before you watch this video, to work out the practice test to the best of your ability. Come back and check your answers, and then watch especially the problems that you got wrong. Obviously, you're welcome to watch the whole video, but see how much you can do on your own. So in just a second, I will show the answers for 11 through 20, so pause the video if you need more time to check your answers. Alright, here are the answers for numbers 11 through 20. If you need more time to check your answers, simply pause your video. Up next, we will work out and explain each problem. Alright, here's problem number 1. It asks which of the following describes the triangle below, and then it gives us this triangle right here. And I guess maybe a good thing for us to notice right off the bat is that it has a right angle. So we know that triangles can be right triangles or acute triangles or obtuse. And as soon as we see that right angle, we know that it is a right triangle. It can't be an acute or an obtuse triangle. In fact, we can come down here. It can't be an obtuse triangle and it can't be an acute triangle. It is a right triangle. The next thing we should probably notice is that it has these sides right here, and these sides are both marked 4. In other words, they're the same length. We might even go to the trouble to put like tick marks on them. Okay, so what's it called when a triangle has two congruent sides? Well, that makes it an isosceles triangle. In fact, this is an isosceles right triangle. And if you know what you're looking at, you know that's another name for the 45, 45, 90 triangle, special right triangle that you learned about in this unit. So in fact, one of the choices here is that it's a 45, 45, 90. That's true. All isosceles right triangles are 45, 45, 90s. Okay? It asks us if it's isosceles. Well, yeah, it is isosceles. Two sides are the same, so we should pick that. And then it asks us here if this is a 30, 60, 90. Well, the angles are 45 and 45 and 90, not 36 and 90, so that would not be the right answer either. Okay, so on the test, could you imagine this being a choose all that apply problem? And you maybe just carefully look through the possibilities and use what you have learned about whatever shape they give you to figure it out. That's what you should do. Alright, here's number 2. It says approximately how tall is the street light? So they are trying to get us to figure out how tall is it right there. And they've drawn this little triangle to kind of help us see what's going on here. And I think I'm going to take a moment. There's basically 3 things that we have studied in this unit. We have studied trig, we have studied Pythagorean theorem, and we've studied special right triangles. Okay? And what you need to be able to do is see a problem on the test and figure out like which one of these 3 things you need to do. In other words, if you have a problem and you're supposed to do Pythagorean theorem, but you think it's a trig problem, so you try to do trig on it, it will mess you up over and over again. So here's the thing they all have in common. These all go with right triangles, which was the main thing we studied in the whole unit. So if you see a right triangle, you kind of know it's one of these three things. So when do you use trig? You use trig when you have a right triangle and you know one side and you know one angle. That's a trig problem. Okay? When to use Pythagorean theorem? Well, when it's a right triangle and you have 2 sides. That's when you should use Pythagorean theorem. And special right triangles, well, there's 2 types. There's 30, 60, 90s, and there are 45, 45, 90s. So here's the deal. If you have these angles, then you should do it that way. If you don't have these angles, then you are probably using trig. So let's kind of jump back over to this problem. It is a right triangle, and I have what? I have one side, and I have one angle, so this must be a trig problem. And on any trig problem, you need to know which ratio to use, and that funny word your teacher undoubtedly shared with you, SOHCAHTOA, that could get written on your test like immediately when it gets passed out. This will help you pick the right ratio. So On this particular trig problem, if this is my angle, then this side is the opposite side, and this side is the adjacent side. And I always think it makes sense to kind of check the third side that's not being used and make sure it is what it's supposed to be. That way you didn't make a mistake. So the one side we're not using is the hypotenuse. Is this side over here the hypotenuse? The answer is yes. All right, so if I'm using opposite and adjacent, this must be a tangent problem. So the tangent of a 43-degree angle must be equal to, and let's see, it's SOHCA TOA. That means the opposite side has to go on top. That would be H. And the adjacent side has to go on the bottom. All right, we've written our little trig equation. I will point out, your teacher might have you solve these slightly differently than I'm about to. If you're comfortable with the way your teacher does it, you should just keep doing it that way. I ask my students to notice that our variable is being divided by a number. So to undo that division, we would multiply. And the rule in algebra is anything you do to one side, you have to do to the other. Okay, these will cancel, so H equals 7 times the tangent of a 43-degree angle. At this point, you would grab your calculator and type in that calculation and work it out. It comes out to be 6.527, and preferably we want you to round it off at the nearest tenth or 1 decimal place. That means you look at the number immediately to the right and use it to do the rounding. And 2 would do what to 5? Leave it or move it up? It would leave it. So our final answer would be 6.5 feet. That's how tall that post is. But keep in mind this general idea of how you figure out what to do, what you've learned. Like when do you do what? Trig, one side, one angle. Pythagorean theorem, two sides. And special right triangles when your angles are those particular angles. All right, here's problem number 3. They say find the diagonal of a square, or in other words, the length of the diagonal of the square when the square has a side length of 14. This is one of those rare geometry problems that doesn't have a picture. So you guessed it, we should probably draw our own. So I'm going to draw my own square here. And it says something about a diagonal. So how do you get the diagonal of a square? Well, you just connect two non-consecutive vertices, and there's our diagonal. I'd probably be wise to remind myself that squares have right angles. I'm going to fill all those in. And what else makes a square a square? What about the sides? Well, the sides are all congruent. That happens in a square as well. Okay, and probably what I should do at this point is to let us all notice that that really means that right here, if we just look at half of the square, this is an isosceles right triangle, because there's a right angle there and these two sides are congruent. In fact, I'm going to go ahead and fill in that these angles must be, it's a 45, 45, 90. Okay, and let's see, they tell me that the side length for the square is 14. In fact, all the sides are 14, right? That's what happens in a square. So if this is an isosceles right triangle, I can use that pattern that your teacher taught you about how to figure out the hypotenuse. And your teacher might do it differently, but we would notice, I would tell my students that, well, if it's a 45, 45, 90, then we're working with the magic number, square root 2. And I really just have to decide if I should multiply by that square root 2 or if I should divide by that square root 2. And if I look right here, I'm going to go from a leg to a hypotenuse. Does this 14, this side over here, does it need to get bigger or smaller to be the hypotenuse? Well, that hypotenuse is bigger. That 14 will have to stretch out, and the way you get it to stretch out is to always multiply. So we would do 14 times square root 2 and we would get 14 square root 2, and that would be the length of the hypotenuse. So if they give you any problems on the test that don't have a picture, taking the time to draw one is going to help you out. All right, here's problem number 4. They ask us what is the measure of angle A, and they give us a right triangle where we know all 3 sides. So hopefully you see this measure of the angle and it reminds you of inverse trig. Okay, in other words, if we have a right triangle, we know some sides, we can figure out the angles by using trigonometry backwards. Okay, this almost works the same way as using trigonometry in the normal direction. So I'm going to notice that I'm working with angle A. Now, I have three sides here. In other words, I could really work out this problem using sine, or using cosine, or using tangent, but you're not supposed to use all three. You just have to pick one. So here's what I think I'm going to do. I'm going to use the 56. What side would that be? That'd be an opposite side. And then I'm going to use the 65, and that would be the hypotenuse. So if I'm using opposite and hypotenuse, that would be what? SOHCAHTOA, S-O-H. So to find the measure of angle A, I'm going to use the sine ratio, except I'm not going to use the normal sine ratio. I'm going to use inverse sine ratio. Okay, what I need to do next is input the ratio of sides so it will output the angle for me. SOHCAHTOA tells me that opposite will be on top and hypotenuse will be on the bottom. So my opposite side is 56 and my hypotenuse is 65. And at this point I would grab my calculator, and remember, to get inverse sine you almost always have to press shift. So you press that, hit the sine button. Okay, and then I need to type in 56 divided by 65. I'll hit the equal sign, and it comes out to be 59.489. And usually we just round to the nearest whole degree, so I would look at the 4, and it would tell me to leave the 9. So the measure of angle A should come out to be 59 degrees. Okay, you could have done this problem totally correctly using cosine or using tangent. You would still get 59 degrees as long as you set it up right. When they give you all three sides, you just pick 2 and use the ratio that goes with the 2 sides that you picked. All right, here is problem number 5. They give us 2 triangles and they do something very generous to us. They tell us that the 2 triangles are similar. They probably didn't need to tell us that because hopefully you remember the angle-angle similarity postulate from our last unit. If 2 triangles have 2 pairs of congruent angles, they're similar. We can see these both have a 90-degree angle and they both have a 35-degree angle. So we should know that they're similar. Okay, and I guess we'll also notice that in this smaller triangle, they gave us the length of the 2 legs. In this bigger triangle, they gave us the length of one of the legs. And here's the first question. Find the side length of the smaller triangle. So we can see that this right triangle right here is missing this hypotenuse length. So how would we figure that out? Well, actually, you have some choices. Well, if they gave us 2 sides, could we use Pythagorean theorem? Yeah, you can. Well, what would you use trig for? Well, trig would be one side and one angle. Do you notice you have that too? So you actually have a choice here. I guess maybe let me run this past you. Could you use special right triangles on this problem? Well, to use that, you would need 45, 45, 90 or 30, 60, 90. Do you see that 35-degree angle wouldn't let us do that? I think the easiest way to work this one out would be to use trigonometry. So I'm going to notice that my missing side right here is a hypotenuse. And the Pythagorean theorem says leg squared plus leg squared is equal to the hypotenuse squared. So that would be what? Leg squared plus leg squared is equal to, I'm just going to call it x squared. Let's see, 8 squared, that would be 64 plus 36 is equal to x squared. I'm going to drop down here a little bit. If you add those together, you get 100 is equal to x squared. But I don't want x squared, I just want x. So to undo the squaring, I would take the square root of both sides, and that means x is equal to 10. So that's my first answer. That missing side length in the smaller triangle is 10. All right, now it says find the missing side lengths of the larger triangle. So we don't know this one, and we don't know this one. Okay, and you have some more choices here. You could use trig, because we have one side and one angle, so you could do it that way. Maybe I'm going to call this y, and I'm going to call this z. I think it would be faster to use the proportionality that we learned about in similar triangles in our last unit. So since these are similar, and I know that this 6 goes with this 9, I could use the 8 and 10 to figure these out with 2 separate problems. So here's what I'm going to say. I'm going to say that 6 in the small triangle goes with 9 in the big triangle, the same way that 8 in the small triangle goes with y in the small triangle. Okay, I think I'm going to work out how long that side is now. So I notice that 6 over 9 reduces. I'm going to divide 3 out of both of them. Into the 6 it goes twice. Into the 9 it goes 3 times. And to solve one of these equations that's called a proportion, I would cross multiply. So 2y equals 3 times 8, 24. Don't forget your equal sign right there in the middle. And obviously if I divide both sides by 2, y equals 12. So this isn't y anymore, it's 12. Does that even make sense? Well, do you notice this triangle's bigger than this one? So if this side was 8, does 12 seem reasonable? Yeah, it does seem reasonable. If you get done with your problem and the answer doesn't seem reasonable, you should go back and check your work. You might find that you made a mistake. All right, now I'm gonna solve for this hypotenuse. So same thing, 6 goes with 9, the same way that this side 10 would go with my z that I'm trying to figure out. I already know that this reduces down to 2/3, and I'm going to do some cross multiplying. So 3 times 10 is 30, and that's equal to 2 times z. That would be 2z. And to get the z all by itself, I'll divide both sides by 2. So z would equal 15. And those would be my two answers. You could get those same exact answers by just using trigonometry, but I think this is faster. Alright, here is problem number 6. They ask for the tangent for angle A. That's the tangent ratio for angle A. And this might just, maybe I won't write the whole SOHCAHTOA. If I see tangent, maybe I just pop into my mind SOHCAHTOA, which tells me the tangent ratio has to be the opposite side divided by the adjacent side. So if I want the tangent of angle A, I just need, let's see, here's angle A. So which of the 3 sides would be the opposite side? Well, the opposite side is 12. So 12, it's going to be SOHCAHTOA. 12 goes on top. And then the adjacent side goes on the bottom. Well, who's the adjacent side? Well, 13th, the hypotenuse. So the tangent of angle A, or the adjacent side, would be that one. And that's going to be on the bottom. And as simple as that might seem, that right there is the tangent ratio, 12 divided by 5. I'll remind you that trigonometry is really based on some simple ideas, and you need to be careful that you don't overthink it. Okay, here's number 7. They ask us to figure out the values for A and B, and they tell us C, so maybe I'll cross C out here and put in a 12. And hopefully you notice that this is a 60-degree angle. Anytime you see a 30-degree angle or a 45-degree angle or a 60-degree angle, one big thing should jump out in your mind. I have to use my special right triangle patterns. All right, so you see that 60, and you can almost jump over here right away and fill in that this angle must be 30. Okay, so I'm going to teach this problem the way that my class has learned it. If it's different than what your teacher taught you, just stick with what your teacher taught you unless you're having a hard time understanding it. But I always tell my students that in the 30, 60, 90 special right triangle, the short side is the one that you want to focus on. So you should find your short side, and it's easy to find because the short side's always across from the smallest angle. So there's my 30. This is the short side right here, and I have my students scribble on it. Then I have them attach the 2 magic numbers that go with this special right triangle. Those are square root 3 and 2, and I tell them that the square root 3 goes next to the square. Get it? Square root 3 next to the square, and that means the 2 goes on this side. And what I tell them is you multiply by that magic number if you're going bigger, and you divide by that magic number if you're going, if you need to make the side smaller. Okay, so here's the 12, it's the hypotenuse, and I am going to the short side. So you tell me, are we going bigger or smaller? Well, that 12 is way bigger than this A side, so we are going smaller, and that means I have to take this 2 and divide by it. Okay, so what is 12 divided by 2? Well, it's 6, so there's my first answer. Okay, then I'm going to take this 6 and I'm going to try to figure out the medium side. So if I'm going from the small side, the short side, to the medium side, that 6 needs to grow, and that means I'm going to have to multiply this time. And who am I multiplying by? The square root of 3. And 6 times square root 3 actually just comes out to be 6 square root 3. And right there, those are the two side lengths I needed to come up with. Those are the A and B values. All right, here is problem number 8. They give us this funny shaped polygon and ask us to figure out the value of this obtuse angle right here. And maybe what I'll have us notice first is that this polygon has 1, 2, 3, 4 sides. So what would we call it? We would call it a quadrilateral, right? It's a quadrilateral, and basically we just have to have memorized that all 4 angles in any quadrilateral add up to, you tell me, how much? 360 degrees. So if I already know 3 of them, and I do know 3 of them, I can add those up, take it away from 360, and whatever's left is my measure of this last angle. So let's add them up. That would be what? 79 plus 59 plus 74. Let's see, 9 plus 9 is 18, plus 4 more is 22. Carry my 2. 9 plus 5 is 14, and 14 plus 7 more would be 21, and that's the sum of those 3 angles. Now, I'm going to take those 212 degrees away from 360 degrees, and let's see. I can't take 2 away from 0. Actually, ideally, you would do this on your calculator, right? That way you don't make any arithmetic mistakes. So let's see. I'm going to borrow 10 minus 2 is 8. 5 minus 1 is 4. We get 148 degrees. That would be the measure of that angle. In a quadrilateral, all 4 angles add up to 360 degrees. All right, number 9 gives us 2 triangles and asks which must be true about the triangles. And I guess we'll just go one by one. Well, maybe before we do that. Do you notice these are both isosceles right triangles? And I should think to myself right away, oh, isosceles right triangles, that means these are 45, 45, 90. In fact, both of them are 45, 45, 90s. All right, now let's get back to this. All right, first statement, we're going to choose it if it's true. Triangle ABC is similar to triangle DEF. Well, they're not congruent, right? Can you see that that one triangle is way bigger than this one? They're not congruent. But they could be similar if they're the same shape. Well, what makes them the same shape? Making them the same shape is angle, angle. So do 2 angles match 2 angles in this? Yeah, actually all 3 angles match. That is true. You would choose that. Okay, here's the next question. Does the tangent of angle C equal the tangent of angle F? All right, so here's what I'm going to do on this one. I'm going to let's see. Tangent of angle C. What is tangent? It's SOHCAHTOA. So that is opposite over adjacent, right? So if this is angle C, opposite over adjacent would be these 2 sides. Well, can you see that these are the 2 congruent sides? Like, what if this side was 6? What would this side be? It would be 6. And what's 6 divided by 6? The tangent of angle C is actually going to come out to be 1. What if it was 8? I don't really know that it's 6 and 6, but whatever it is, when you divide them, it's going to come out to be 1 because they have to be the same. So would the same thing happen for tangent of angle F, opposite over adjacent? Do you notice you're going to end up dividing the same 2 numbers into each other again? And so you will get 1 again. So are those actually equal? Yes, that's true. Okay, next thing I'm going to do, if these are similar, maybe some of the sides are proportional. Let's see if they pick the right sides. So they're saying BC goes with EF. Well, those are corresponding sides. The same way that BA goes with ED. Do all those sides, are they corresponding? Yeah, that's true. That's true. Okay, my triangles are getting really ugly now. Maybe I'll erase them up a little bit. Okay, the next question was, does angle A, is it congruent to angle D? Well, yeah, they're right angles. That's true. And are both of them 45, 45, 90 triangles? Well, yeah, they are. That's another name for the isosceles right triangle. So in this particular problem, all 5 of those statements are true. Number 10 gives us triangle DEF, which we can notice is a right triangle, and all they want us to do is complete the following statements about the sine of D and tangent of angle F. And since it's all about trig, I'm going to go ahead and write out SOHCAHTOA. And hopefully that will help me out. So for the sine of angle D, here's angle D, I should use opposite and hypotenuse. So who is the opposite side? Right, we're going to do opposite and hypotenuse. The opposite side is segment EF. And who's the hypotenuse? That would be DF right there. So there's my sine ratio. Okay, and how about for the the tangent ratio? It would be what? Opposite over adjacent. And this time we're going to look at angle F. So who is opposite? That would be segment ED. And the adjacent side is right here. That's segment EF. So there's those ratios. All right, number 11. They give us these like two triangles that are kind of connected, and they want us to figure out the measure of angle 1, the measure of angle 2, and the measure of angle 3. Probably this will use some angle relationships that we learned about back in semester 1, so hopefully those are still floating around there in your brain. Let's kind of do them in order. So the first one they want is angle 1. Well, do you notice that these two angles right here are what kind of angles? Vertical angles. And vertical angles are always congruent. So if this one is 45, this one would also have to be 45 degrees. All right, we got that one figured out. Okay, how about angle 2? Well, what I should notice about this one is that all three of these angles are inside the same triangle, so I know that they all add up to 180. So on my calculator, I should probably just add up 63 and 45. That's going to come out to be 108. And I will subtract away those 108 degrees from 180. Please be careful to use 180 and not 360. Triangles come out of 180. Quadrilaterals come out of 360. And this would come out to be 72 degrees. So there's my answer for angle 2. It's 72 degrees. Sometimes it's smart to write that on your picture. All right, and finally for angle 3, well, now that I know this one, I have two of the angles inside this triangle. I can do the same thing. So adding those together, I'm going to get 110 degrees, 45 plus 65. And if I subtract that from 180, I should be left with 70 degrees for that angle 3. Okay, and you just use some of those relationships that we learned back in semester 1. All right, number 12 gives us this four-sided quadrilateral, and they tell us something really important right here. It is a rhombus. So before we get to some of these questions, let's remind ourselves what that means. Well, if it's a rhombus, then all four sides are the same. It's like a slanted square after all. Okay, and a couple other things you need to remember about a rhombus is where the diagonals intersect. They're intersecting right here at point X. In all rhombuses, those always make a right angle, right? The diagonals are perpendicular is the way that we would say that. And if you pay enough attention, you'll notice they told us this angle right here is 60. And that this side length is 8. In fact, all the side lengths are 8, and that means every one of these little triangles is the same. Because a rhombus is a type of parallelogram, this diagonal gets bisected by this one, and vice versa. So we have kind of all these relationships. If this is 60 and this is 90, this would be a 30-degree angle. We can actually work out all these problems using some of those patterns, including the 30, 60, 90. In fact, I might as well work that out. I'm going to actually redraw that triangle off to the side. So here's my 30, 60, 90. So you tell me, this side 8, which side would that be in this triangle over here? Well, it's the hypotenuse. And the next thing I'm going to do is do my little pattern to figure out the other two sides. Well, here is my short side across from the 30-degree angle. Square root 3 next to the square and 2 on this side. Those always get attached to the short side. So bigger or smaller? That's smaller. So I'm going to divide by 2 and get 4. Now from the short side to the medium side, that's bigger. I need to multiply. It would be 4 square root 3. So let's see if I can write those in. This is 4, and this side is 4 square root 3. In fact, I can go one more step. Because the rhombus is a parallelogram and the diagonals get bisected, This 4 is actually over here as well, and that 4 square root 3 is over here, and all of these are also 8 because of that. All right, I think I'll be able to figure some of these out. So the first question, what is the length of XW? Well, I just worked that out. It's 4 square root 3. And what's the length of WS? WS is from here all the way over, so that's a 4 root 3 and another 4 root 3. 4 root 3 times 2 comes out to be 8 square root 3. The length of segment XT, I figured that out as 4. And then finally the length of segment TR. Okay, all the way across, if this one's 4 and this one's 4, that's 4 times 2, that would be 8. Okay, so like I said on that first problem, like noticing when you have a 30, 60, 90 or a 45, 45, 90, or when you should use trig versus when you should do Pythagorean theorem, that's like the heart of the whole test. All right, number 13 gives us a triangle, and they want us to make an equation and solve it in terms of x. So let's notice that we have a right angle, and I know one angle and one side, and I'm solving for another side. So can you see that this is definitely a trig problem? All right, so let's make our trig equation. If this is my angle, what would the x be? Well, that's an adjacent side. And what would the 20 be? Well, that's a hypotenuse. And the trig ratio that uses adjacent and hypotenuse is ca, right? Adjacent and hypotenuse, that's a cosine problem. So the cosine of a 63-degree angle is equal to, all right, so ca, so adjacent goes on top, that would be x, hypotenuse goes on the bottom. All right, let's get the x by itself. To undo the dividing by 20, I would multiply by 20. And those cancel. So x equals that, 20 times the cosine of a 63-degree angle. Okay, we type that all in on our calculator. It comes out to be 9.079. We're going to round off at the nearest tenth. And actually, I just remembered something. This problem doesn't have you work it out. In fact, I should read my own direction. It says, write the equation in terms of x. So all that really means is to get x equal to it. And that means that it's equal to 20 times the cosine of a 63-degree angle. Okay, so, and this is a multiple choice question on the test. You'll notice that they didn't work it all the way out. All you have to do is solve it in terms of x. And that's a fancy way to say get the x by itself and tell me what it's equal to. So that's the equation in terms of x. All right, number 14 gives us a map of Whittier. This is actually a map of Whittier. Looks like South Whittier to me. It says McQueen and Mater drive from A to B. So everyone sees point A. Here's point A. And here's point B. Both of them drive from A to B. But they don't drive the same way. Mater drives along Imperial and then takes a 90-degree left turn onto Valley View. That's actually pretty close to my house. I won't tell you where that's at, so you can't egg my house. Okay, haha. Okay, McQueen doesn't do it that way. McQueen just drives right along Leffingwell from A to B. Okay, what do you think? McQueen takes the shorter route? Yeah. Okay, so here's the question for this problem. Now, I'm going to warn you, the question on the real test is similar to this, but they're going to ask you a different question, and you should read that question and make sure you answer their question. It won't be exactly this question. So the first question is, how far did Mater drive? Well, he is the one that went along Imperial and then went along Valley View. So he drove 1,200 feet. Is that what it says? Yeah, 1,200 feet. And then he drove 500 feet. So you just add those together to get how far he drove, right? So 1,200 plus 500, you could do this on your calculator, comes out to be 1,700 feet. Okay? All right, so that's how far Mater drove, so 1,700 feet. How far did McQueen drive? Well, they didn't tell us that, so maybe here's where that 90-degree left turn, this is a right angle. And do you notice that this is a right triangle where we know two sides? So if you know two sides and you want to find the third side, wouldn't that be Pythagorean theorem? It's always Pythagorean theorem. And what is this side that's missing? We'll call it x. What is that side? A leg or a hypotenuse? That is a hypotenuse. So we're going to say leg squared, 1200 squared, plus the other leg squared, that's 500 squared, is all equal to x squared. All right. 1200 times another 1200 comes out to be 144 and 4 zeros. 1, 2, 3, 4. Of course, you'll have a calculator to work all of this out. And 500 squared comes out to be, what would be that? 25 and 4 more zeros. 1, 2, 3, 4 is all equal to x squared. So if you add that together, you get 169 and 4 zeros is equal to x squared. Well, we don't want x squared, we just want x. So if I take the square root of the whole thing, x ends up comes out equaling 1,300 feet. That is how far McQueen drove. Okay. Now the question on the test, like I said before, will ask you something about those distances. What could they ask you? They could ask you how far they both drove together. Probably Adam. They could ask you like how much farther did Mater drive, or they could ask you how much driving did McQueen not have to drive since he took the shorter route. You'll have to just check the question on the test to see what they ask you. All right, problem number 15 asks us to figure out the perimeter of this quadrilateral. It says to show all the work. So let's see what they're talking about. The perimeter, that would mean what? The length of the outside edge. So here's some things we know this is 8, but that I guess that stops right there, right? I guess I'm just noticing right now that my picture is not very clear, but that I need to have something right here that shows that that 8 stops right there. So I also need to figure out, so that's 8. I need to figure out how far it is right here. I need to add in how far it is right here. Actually, I already know that it's 7. I need to use this distance right here, and we'll talk about that in a second. Then I need this one here, and I need this one right here. So those are all the pieces. Once I know how long those all are, I can just add them all up. All right, let's get some easy ones first. Oh, I just noticed there's a whole bunch of flaws. This is a new problem, and it has some flaws on it. All right, so first of all, this is basically like a little rectangle right here. Okay, so if this side's 8, how far is this side? It's also 8. Okay, and then the next thing, it needed to show that this was the same length as that, and that was just left off. So, oh wait, I'm doing this problem wrong. Sheesh. Sorry about that. Let's go back. Haha. So what we would notice on this problem, if I wanted to know this red side, don't I have 2 sides in my right triangle, and I want to know the third side? So couldn't I use Pythagorean theorem to work that out? And how about this missing side here? Leg or hypotenuse? This is a missing leg, and I'm going to call it x. So leg squared plus leg squared must equal my hypotenuse squared. Okay, let's work out how long that is. So let's see, that'd be x squared plus 16 is equal to 49. I'll subtract 16 from both sides. So x squared will now equal 33, and I'll take the square root of both sides, and x ends up equaling square root 33. So maybe I'll erase that and say, all right, I figured it out. It's square root 33. By the way, how much is square root 33? It's a little bit less than square root 36, so probably 5 point something. But anyway, I don't have to worry about that. I'll just call it square root 33. All right, here's the next thing I should notice. I should notice that they told me that this is a 30-degree angle. So this must be a 60-degree angle. Okay, and if I know it's a 30, 60, 90, couldn't I figure out these 2 sides? And once I do that, it looks to me like I'll be able to add everything up. So first things first, let's find the short side. It's across from the 30-degree angle. Square root 3 goes next to the square, and the 2 goes on the other side. So bigger or smaller? That's smaller. That means I'm going to divide, and 4 divided by 2 would be 2. Okay, there's another side I've got worked out on this quadrilateral. Actually, is it a 1, 2, 3? Yep. No. 1, 2, 3, 4, 5. Oh, it's not even a quadrilateral. It's a pentagon. All right. Anyway, okay, if this side's 2, then I'm going to use that 2 to figure out this side, bigger or smaller. Well, that yellow side is bigger than that blue side, so it's bigger, and that means I'm going to multiply by square root 3, and that means it comes out to be 2 square root 3. Okay, so the last thing I need to do is just take all of those and add them up. I need to add up the 2 root 3, the 8, the square root 33, the 7, the 8, and the 2, and I'll get my whole answer. So here's what I'd like you to notice. How many of those are whole numbers? Well, the 2 is, the 8 is, the 7 is, and this 8 is. The 2 square root 3 and the square root 33 are not whole numbers, so you actually can't add them in. So let's just add up the ones we can add up. 2 and 8 would be 10, 10 and 7 would be 17, and 17 and 8 would be 25. So the perimeter of this pentagon would be what? 28 plus that 2 square root 3 plus that square root 33 that we can't add on the way it is. And even though that answer looks a little crazy, that's what it would be. If those came out to be things you could add on, then we would add them all up. But 2 square root 3 can't get added with 28 or square root 33. All right, number 16 gives us a triangle, and they ask us to figure out all the missing angles and all the missing side lengths. The name for doing this is called solving a right triangle. That's where you figure out everything. Okay, and let's start with the easy stuff. We need to figure out angle C. Well, if you can't find out what angle C is by looking at the picture, you need a lot of help. So we can all see that that's 90 degrees. Let's go ahead and fill that in. All right, we already got a box filled in. Okay, and let's stay with the angles. If you know these two, couldn't we figure out that angle right there, right? In fact, in my class, we talked about how the acute angles in a right triangle are complementary. In other words, their 90 with this 90 makes 180. So if I just do 90 minus 38, I will end up with 52 degrees, and that is the measure of that angle. So just like that, we've got all the angles done. And really, all we have to figure out now are these two sides. I've got this side here. I'm going to call this y. So if I figure out x and y, that's the length of AB and BC, I'm good. All right, so first thing I'm going to notice is that this problem has one side and one angle. One side and one angle. What should we use when we have one side and one angle? This is going to be a trig problem. Okay, what if on the real test they give you two sides? Well, instead of doing trig, you would do Pythagorean theorem. And what if on the test one of the angles was a 30-60-90 or a 45-45-90? Well, then you would use that. But in this particular case, one angle and one side, that should be a trig problem. So let's see if we can figure out what the x is. So if this is my angle, what would the x be? Well, do you see that that's an adjacent side? And how about the 15? What would that be? That's opposite side. So who uses adjacent and opposite? That would be a SOHCAHTOA. Tangent uses opposite and adjacent. So the tangent of a 38-degree angle is equal to SOHCAHTOA. Opposite on top, that would be 15. And x on the bottom. All right, so we've got our trig problem all worked out. Now we need to do some algebra to get the x where we want it. And the x is on the bottom. That is bad. What would undo dividing by x? Well, the opposite of that would be multiplying by x. If I multiply by x on one side, I have to multiply it by x on the other side, so those will cancel. And now I have x times the tangent of a 38-degree angle, and it equals what? What's left after I canceled those x's? 15. Okay, one step closer to having x by itself. X is still being multiplied by the tangent of a 38-degree angle, so I need to divide by that. And of course, if you do it on one side, you have to do it on the other. So those cancel, and x equals that right there. So we're going to grab our calculator. We're going to type in 15 divided by, we're going to do the tangent of a 38-degree angle, and it comes out to be 19.199, and they want us to round these side lengths to the nearest tenth. So that means I'm rounding off that 1. Well, what would this 9 do to that 1? It would round it up to 19.2. And let's see, who is this? This is BC is 19.2. BC is 19.2. All right, I've got 5 of the 6 boxes filled out. I just need to work out the length of AB, so let's do another trig problem. So if this is my angle, the 15 is still opposite, but what would the y be? Well, that's the hypotenuse. All right, so who uses opposite and hypotenuse? Well, that would be SOHCAHTOA. Sine uses opposite and hypotenuse. So the sine of a 38-degree angle would have to be, let's see, SOHCAHTOA, S-O-H. Opposite is still 15, and the hypotenuse is y, and let's solve for the y. Well, same as before, we're dividing by y, so we should multiply by y. Multiply both sides by y. Those will cancel. So y times the sine of a 38-degree angle is equal to, those canceled, I got 15. And to get rid of that multiplying, I should divide by the sine of a 38-degree angle. Okay, so y equals that right there, and I'm going to grab my calculator again, type in a new problem. 15 divided by the sine of a 38-degree angle. It comes out to be 24.364. And if I'm rounding at the 10th, I'm going to look at the 6. The 6 moves the 3 up, so my final answer would be 24.4. And that's the side length for that one right there. And we have just solved that right triangle. All right, number 17. They give us another right triangle. Surprise, surprise. Actually not. That's what the whole unit was about. And they want us to figure out the length of segment BC. All right, so let's see. Should we use trig? Should we use Pythagorean theorem? Or should we use special right triangles? Well, let's talk about the special right triangles first. Do you notice they didn't give us any of the angles? So should we be using 45, 45, 90 or 30, 60, 90? No, they didn't tell us what those were, so we don't do that. Should I use trig? Well, trig uses one side and one angle. I don't have an angle. What does Pythagorean theorem use? It uses two sides. That's what this problem is. It's a Pythagorean theorem problem. Okay, our next job is to figure out what our missing side is. What is our missing side? Is it a leg or is it a hypotenuse? This is a leg, and I'm going to call the variable x. So what's the Pythagorean theorem say? Leg squared plus leg squared is equal to the hypotenuse squared. In this case, leg squared, that would be what? X squared plus the other leg squared, 3 squared, is equal to 9 squared. All right, there's nothing you can do with x squared. It'll just stay x squared, but 3 squared would be 9. Be careful you don't accidentally multiply by 2. That means 3 times itself twice. And 9 squared would come out to be, what would that be, 81? If you subtract 9 from both sides, then we end up with x squared is equal to 72. And we will take the square root of both sides, and that means x is equal to square root 72. Okay, and what they might have you do on a problem like this is simplify the radical. There's a good chance your geometry teacher talked to you about this. So here's the way I teach my classes. If you know a different way that your teacher emphasized to you, go ahead and switch to it. But we would look and see if we can find any perfect squares inside of 72. In other words, does 4 go into 72, or 9, or 16, or 25? And I definitely can see that 9 times 8 does make 72. Because 9 is perfect, you can take the square root of it. The square root of 9 would be 3. So I have just simplified this to be 3 square root. And the 9 came out. Who's still trapped inside? The 8. Okay, we should actually double check to make sure the 8 doesn't have any perfect squares inside of it. Does it? Well, yeah, actually 4 is inside of 8. What would that be? 4 times 2. So what would the 4 come out as? It would come out as a 2, right? And we're going to multiply these numbers on the outside. 2 times 3 would be 6. And who never came out? This 2 right here. So 6 square root 2. If it asks you to simplify after you do the Pythagorean theorem, you got to make sure you're ready to do that. So 6 square root 2, which is the same as square root 72, but this is the simplified version of it. All right, here's number 18. Number 18 is a word problem. There is a word problem on the retake, or not on the retake, the regular test. Okay, and right here they give you the big hint. This hint will not be on the test. You just have to remember that when they give you that word problem, like drawing and labeling up your picture as carefully as possible is like 90% of the problem. The actual trig that you do to work out the problem is not so much, as long as your picture is right. So Judy is flying a kite on flat ground. So I'm going to start drawing my picture. Here's my flat ground. Here's Judy. And she's flying a kite. Okay, she has let out 60 feet of string. All right, so maybe I can already label that 60 feet of string. Well, what in this picture is the string? Well, there it is from the kite to her hand. That's 60 feet. So let's label that up. And okay, and the string and the ground, the string and the ground, the string and the ground make a 52-degree angle. So this angle right here must be 52 degrees. Judy's friend Wendy is standing directly underneath the kite. All right, so another person, here's the kite. Here is Wendy standing directly underneath it. In fact, I might even draw down and fill in my right angle right there. All right, so there's Wendy. I guess I'll give her some hair too. Okay, and the question is, how far apart to the nearest tenth of a foot are Judy and Wendy standing? So they want to know how far apart are they? That looks like my X right there. Okay, I've got all the information. Let's notice I have what? One angle and one side, and I'm solving for a side. This is a trig problem. So let's set it up. If this is my angle, what would the X be? Well, it is adjacent to that angle. And how about the 60? That 60 is the hypotenuse. And which trig ratio uses adjacent and hypotenuse? That is what? So ka uses adjacent and hypotenuse. So the cosine of a 52-degree angle is equal to so ka. Okay, adjacent goes on top, the hypotenuse goes on the bottom. To get the x by itself, I'm going to undo that dividing by 60 by multiplying by 60. I have to do that on this side as well. Those 60s will cancel, so x equals 60 times the cosine of a 52-degree angle. I've got my calculator. I'm going to type in 60 times the cosine of a 52-degree angle. It comes out to be 36.939 actually, and they want it to the 10th. So that's the 10th right there. What would the 3 do to the 9? It would leave it. So the answer is 36.9 feet, almost 37 feet apart with that angle involved. Okay, and the big idea is to draw a picture and put a lot of thought into where you put the measurements. Most people who miss this problem on the test don't put the measure, they write the 60 over here. Or they'll put an angle measure that's like on a side instead of on one of the angles. So pay as much attention to that as you can. All right, problem number 19, they give us two triangles right here. One's facing one way and one's facing another. Maybe we will notice that this particular triangle, they gave us what? Two sides. Probably doing Pythagorean theorem later in the problem. Yeah, probably. And this triangle, they gave us this side and this angle. So a side and an angle, that sounds like maybe a trig problem. Maybe the last thing we'll check, do any of these triangles have a 30-60-90 or a 45-45-90? The answer is no, so that's not what we're not going to be doing that in this problem. Okay, so here's the first question. Find the length of the missing side in the first triangle, or the one over here on the left. So, well, that's pretty much just a Pythagorean theorem problem. And who is my missing side right here? Isn't that the hypotenuse? So 15 squared plus 8 squared is equal to x squared. That if you can work this out on your calculator. 15 times 15 comes out to be 225 plus 8 squared. Oh, why aren't I squaring that? Let me try again. 8 squared comes out to be 64 is all equal to x squared. And if you add those together, you're going to get, what is that? 289 is equal to x squared. If you take the square root of both sides, you might as well try that. Type in 289 and do the square root of that. You might find, or if you're in my class, you could see the 289 hanging from the ceiling. So it comes out to be exactly 17. So this came out to be 17. All right, so we just worked it out, and I showed my work over here. It's 17. Now it says, find the height and base of the second triangle to the nearest whole number. Oh, we're going to round off to the whole number. So they want the height, or the base and the height. I'm going to call this y and z. And if I know one angle on one side, these are some trig problems. So here I go. Let's do some trig. If I look at y, it's the adjacent side, and if I look at the 17, it's the hypotenuse, and that means that would be a cosine problem, right? Ka. So the cosine of a 28-degree angle is equal to a over h. So that's going to be y over 17. And to get the y by itself, I would multiply both sides by 17. Those will cancel, and that's what y equals right there. So on the calculator, 17 times the cosine of a 28-degree angle comes out to be 15.01. 15.01, and we're actually rounding off to the nearest whole number, so the 0 would leave this 15. So this came out to be 15. Okay, next up, let's solve for z. So this is still the hypotenuse, but this one over here would be the opposite side. So this is opposite and hypotenuse. That would be a sine problem, right? Opposite and hypotenuse. So the sine of a 28-degree angle is equal to opposite over hypotenuse, z over 15. I'm going to multiply both sides by 15. Those cancel, and z will equal, grab our calculator again, 15, no, my bad, I should have written 17. Glad I caught that. So it's 17 times the sine of a 28-degree angle, and that comes out to be 7.98. And if I round this off to the nearest whole, that 9 will move this up to 8. So this side is 8 right here. Okay, so my height came out to be 8, and my base came out to be 15. And I showed all my work. All right, here's the last question. Are the two triangles congruent? Well, this one has sides of 8, 15, and 17. And this one has sides of 8, 15, and 17. So all their sides are the same. So here's what I'm going to say. Yes, they are congruent. All right, and why would I say so? Well, side, 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 because of side, 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 triangle congruence postulate is what I would write. Your teacher might even accept side, side, side. Now, on the test, this might come out to be something different, so don't expect it to be exactly the same. All right, number 20. It says Daryl is practicing his rail shots in billiards, or sometimes people call that pool. Okay, so he's going to hit the ball, have it bounce off the side of the pool table, and hopefully head over to one of the pockets and make the shot. Okay, and the question is, what is the total distance the cue ball travels from the start to the moment it hits the 8 ball? And I guess I need to fill in that this is the 8 ball right here. Okay, and, oh, my bad. You guys probably that play pool knew I just messed that up. The 8 ball is this black ball right here. And the cue ball is the white ball. So it's starting right here. Okay, and they want to know how far it's going to travel, or what's its path. It's going to go along here. It's going to hit the rail, and it's going to bounce all the way and hit this ball right here. Okay, and so we basically need to know how long those two segments are. We'll add those up, and it'll tell us how far the cue ball traveled. Now, here's the catch. We don't know how far it traveled there, and we don't know how far it traveled there. These are right angles, and they gave us some information, so it looks to me like we could work out those distances and just add them up. So I think I'm going to call this X, and I'm going to call this one over here Y, and at the end of the problem, I'll just add up X and Y, and it will tell me how far that white cue ball traveled. Okay, so how about this one right here? Well, do you notice we have two sides, and we're trying to find a third side? Is this a Pythagorean theorem problem? Yes. And my missing side is a hypotenuse. So 3 squared plus 4 squared is going to be x squared. And that would be what? 9 plus 16 equals x squared, and that means 25 is equal to x squared. And if I take the square root of both sides, x is equal to 5. So it traveled 5 units when it was, after we hit it till it hit the rail, 5 units. All right, now let's work out what's happening over here. Well, do you notice I have one angle and one side? So it's not Pythagorean theorem this time, it is trig. And if it's trig, the 8 would be opposite, and the y that I'm trying to figure out would be the hypotenuse. And opposite and hypotenuse is a sine problem. So the sine of a 53-degree angle is equal to, let's see, SOHCAHTOA. Opposite on top, that's 8, and y is on the bottom. All right, I don't want y on the bottom, so to undo dividing by y, I'm going to multiply by y. Of course, I have to do that on this side too. Those y's cancel. So now I have 8 on this side, and over here I have y times the sine of a 53-degree angle. Okay, and let's see, that's being multiplied. So if I want the y by itself, I'm going to undo that multiplying by dividing. So I'm going to divide by the sine of a 53-degree angle. Those cancel, and y equals, and let's calculate it out. They want it to the nearest whole inch, so I'm going to round this off to the nearest whole inch. And let's see, 8 divided by the sine of a 53-degree angle equals, it comes out to be 10.01, and if I round it off to the nearest whole inch, the 0 would just leave it, so I would get 10 inches right here. All right, so it went 5 and then it went 10, so the whole distance, maybe I'll write total distance equals 5 plus 10, and that's going to be 15 inches is how far that shot will travel after it bounces to the rail, bouncing off the rail, and then colliding with the 8 ball. That would be the answer. All right, thank you for watching the video. Go back and check out any other problems that are still giving you trouble. Maybe the explanations will sink in just that much more, and you definitely will get a higher grade on your test for having put that time in.